We're moving into a section now called the nature of roots. And in order to understand that better, I always find it helpful to just say, what is a root? And a root is simply a solution to an equation or an x-intercept of a graph. Okay, and once we have that down, the fact that a root is a solution or an x-intercept, then we can start to actually understand what they are asking us for. I know a lot of students, they just learn this very theoretical approach to this section, but actually, why don't we just take a moment and have a look at these three parabolas here, okay? Because we learn the nature of roots with quadratic equations and quadratic functions. So let's just take a look at exactly what this becomes when we interpret it. If you look at the first one here, this parabola here, it's called a maximum value, or sad face parabola, not very mathematical, but that one makes sense to us. It sticks in our brains. Okay, have a look at its x-intercept, because that's specifically what we are looking at. Do you see that it cuts the y-axis here, but nowhere does it cut the x-axis? And so when we get a parabola like that, we can simply say of this, there are no real roots. It's not going to cut my axis anywhere. Okay? Whereas in the second one, have a look there, we have got two intercepts, and there are two very different intercepts. Okay? And so those are real and unequal roots. And then finally, if you look at the last one, that seems to be touching just in the one place. So if we were to solve that equation, we would actually end up with two identical answers. Okay? And so this would also be real roots, definitely real, but these roots would be equal to each other. So that's why it just ends up touching the axis in one spot. Okay, so that's the graphical representation. You get no real roots, you get real and unequal roots, you get real and equal roots. And the other thing that we will soon be able to do is to have a look at whether or not these roots are rational numbers or irrational numbers. In one of our earlier videos on solving quadratic equations, we were introduced to this quadratic formula. So we saw that if we write a quadratic equation in the standard form, then we can determine the a, b, and c values and then substitute to solve for x for any equation. And remember, that would be considered a root, a solution to a quadratic equation. But now that we move on to the nature of roots, we are going to focus our attention very closely on what is happening here underneath the square root sign. So this b squared minus 4ac that we find under the root sign is known as the discriminant. And the discriminant tells us all about the nature of the roots. So in any quadratic equation, if we work out b squared minus 4ac, we need to be able to interpret this answer to be able to answer whether the roots are real, non-real, rational, irrational, equal, or unequal. And let's have a look at exactly how that unfolds. Over here, we've got a whole load of options. So if we work out delta, in other words, we take any equation and we work out what is b squared minus 4ac, we've got certain options that could happen. So we could discover that delta is greater than or equal to 0, or delta could be smaller than or equal to 0. In other words, a negative number. Okay? Those are the first two options. So if delta is negative, think about that. That means that in our formula, b squared minus 4ac, that was underneath a root. And when we have a negative under a root, then we end up with non-real. So if ever you find that your answer to delta is a negative number, that means you can deduce that the roots are non-real. Okay? And then obviously the opposite is true. If it's greater than or equal to 0, then the roots are real. So that's the first fork in the road. Then we've got more options. Okay? If it's greater than or equal to 0, well, it might very well be equal to 0, or it might just be greater than 0. Now, if it's equal to 0, then what we have, and this one's quite easy to remember, is we have equal roots. In other words, we'll probably end up with the same root twice. Think of that parabola that cut the x-axis just in the one place. Okay, but if it's not equal to 0, but it's still a positive number, then we have unequal roots. And then finally, we have one last split. Either those unequal roots are going to be in the form of a perfect square or not a perfect square. Okay, a perfect square is a number like 1 or 4 or 9, where you have two identical factors that multiply by each other. Okay, if delta is a perfect square that is greater than 0, then we have got rational roots. And if delta is not a perfect square, we have irrational roots, which means that they will cut the x-axis, but it'll be at a decimal point that is not terminating and not recurring. So let's see how this knowledge of the nature of roots will play out in some of the questions we might see. So we are asked to determine the nature of roots of the following, and they just give us two quadratic equations there. Okay, so I need to first of all check, is this in the standard form? So I've got a squared, then a, and then just the constant term, and that's fantastic. The reason why I want it in the standard form is because it helps me to identify that a is equal to 3, b is equal to 1, and c is equal to minus 4. Okay, have a look at that. 3, there's nothing written here, so that's the 1, and then minus 4 as the c value. Okay, now I can work out what is delta, because delta is the thing that helps me determine the nature of the roots. So delta is equal to b squared minus 4ac, and I can now substitute in 1 squared minus 4 times a times c. Let's calculate that, and we end up with 49. Okay, now we need to run through our checklist. Okay, either this number is positive or negative, and that means real or non-real roots. Okay, well this is a positive 49, so therefore the roots are real. Then the next thing we check is, does it equal to 0 or not? Because if it equals to 0, then our roots are equal, but if it doesn't, then our roots are unequal. So this 49 does not equal 0, so therefore my roots are unequal. And then finally, I need to ask myself, is this a perfect square? And if it's a perfect square, then the roots are rational. And if it's not a perfect square, then the roots are irrational. Okay? And in this case, 7 times 7 is 49. And so these roots are rational. Okay? And our answer is not complete if we don't run through all three of those questions. Okay? Real or non-real, equal or unequal, rational or irrational. And the only time that we have an excuse not to run through all three of them is if the first one ends up being non-real. Okay, so that's the basic nature of roots. Let's have a look at this second example here. Okay, first thing, it needs to be in the standard form. This one is not, but I can get it there. Okay, let's multiply this 9 into the bracket. So we'll end up with 9x squared plus 9 equals 7. Let's move that 7 too, so that we can save some space. So with 7 on this side, when I move it over, it's going to become a minus 7. So minus 7 equals 0. Okay, so that leaves us with 9x squared plus 2 equals 0. And then, in order to calculate this, it's helpful for me to just say, okay, well, a is equal to, b is equal to, and c is equal to. Okay, a goes with the squared term, so a is equal to 9. B goes with just the x term, and there isn't one, so that means that b just has to be 0. And then c is the constant term, and so that's going to be 2. All right, now delta is equal to b squared minus 4ac, and I am going to substitute in. So b, 0 squared, minus 4 times a times c. Let's see what we end up with. 0 minus 72. Okay, so now I run through my checklist. We start and we say either my discriminant is positive or negative. If it's positive number, then I've got real roots. But in this case, it's a negative number, and so the roots are non-real. And so as long as we have a good understanding of what we're looking for, we can determine the nature of any roots. Okay, so just to recap, remember we ask ourselves, is the answer to the discriminant positive or negative? The second thing we ask is it equal to 0 or is it bigger than 0? And the third thing we ask is it a perfect square or is it not a perfect square? And if you can answer those three questions, you can determine the nature of the roots. Let's have a look at an applied example. So basically taking our knowledge of the nature of roots and then just stretching us a bit with a slightly higher order question. So here we are being asked for which value or values of k will the equation have equal roots. Okay, what do we know about equal roots? Well, let's just make a note for ourselves here. Equal roots meant that the discriminant was equal to 0. Okay, so that's our theory that we needed to know. Now, having a look at it, it might seem very scary. X squared plus 4x plus 2kx minus 9k. There's a lot going on here. But I'm going to apply the same principle that we apply most of the time. And that's to put this in the standard form. Okay, so that's always step 1. So x squared plus, okay, then x's come. So these two each have an x. And then finally, plus 9k equals 0. Okay, so I want to try and figure out what is A, what is B, what is C. But at the moment, the fact that these two terms each have an x is making my life a little bit complicated. But because I've done a number of practice examples, I'm ready for it. Okay, and you can get there too. You just need to keep on practicing. So x squared, what I'm going to do is I'm going to take out a common factor of x here, just from these two terms that I've underlined in blue. So I'll be left with 4 plus 2k, and then plus 9k over there equals 0. So now what you'll see is that I've got my standard form. I've got x squared, then x, and then finally the constant term that has no x's. Okay? So what does that mean? That means I can actually read off the a value, the b value, and the c value. So let's jot that down. A is equal to 1. B is equal to 4 plus 2k. All right, don't panic that there's a k in there. We are going to just keep going, and I think the question will lead us as we go. C is equal to 9k. All right, so in order to have equal roots, I'm now going to tell the teacher who's marking my paper, for equal roots, delta must equal to 0. So let's substitute. So delta we know is equal to b squared minus 4ac. And that must be equal to 0. Okay, b is 4 plus 2k, and that's going to be squared, minus 4 times a times c. Okay, now let's multiply out. 4 times 4 is 16. I'm going to use that shortcut where you work out 2k times 4, that's 8k, and then we double it, so plus 16k, and then multiply the last terms, plus 4k squared, and then 4 times 9 is 36, so minus 36k is equal to 0. All right, now let's again get this into standard form. It's a whole new equation here. Let's put k squared in the front, group our like terms here that contain k, and see what we end up with. So 4k squared plus 16 minus 36, that's minus 20k, plus 16. And now, just looking at it, I can see that each of these terms is divisible by 4. So that's going to make my solving a lot easier. So 4k squared divided by 4, minus 20k divided by 4, 16 divided by 4. There we go. And now, let's just carry on up here so we don't have too much of a space problem. So we've got k squared minus 5k plus 4 must equal to 0. It's quadratic, so that means I'm going to have to factorize it. Okay, k times k gives me k squared. Factors of 4 and 1 will be able to give me that minus 5 if I say minus 4 and minus 1. And then we just do that final check where we say a minus times a minus is a plus, and 4 times 1 is 4. So those factors are good. And so now we can solve, well, either k minus 4 equals 0 or k minus 1 equals 0. And then we go for it. K equals 4 or k equals 1. And so to answer the question, for which values of k will the equation have equal roots? Well, basically, if I were to substitute in a 4 in the place of k or a 1 in the place of k, then I could work out this discriminant and it would equal to 0. And so then the roots would be equal.